Good morning, ladies and gentlemen. Thank you for joining the Rotating Machines Section webinar on Power Generation New Zealand. Before we start the webinar presentation, there is a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their devices. Ensure you have stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the question panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, encouraged to ask questions. A recording of this presentation will be made available on the SAIEE YouTube channel or SAIEE TV. The recording will also be made available on the SAIEE website under Events drop-down menu in the section Past Events and Webinars. This page is updated regularly, so ensure you check back as often as possible for new uploads and subscribe to your YouTube channel for more uploads. A certificate of attendance will be issued a few days after this webinar. But with no further, we're going to present the facilitator for today is Jabu Bembe. Jabu Bembe completed the B.Eng and M.Eng in electrical engineers from the University of Johannesburg. He also completed the BTEC degree from Vaal Triangular Technikon. He holds the government certificate of competency in electrical and mechanical engineer. He has more than 20 years experience working in the electrical machinery repair research industry. He is currently working for the South African Power Utility Eskom as a researcher specializing in asset condition monitoring. He is a member of the Institute of Engineering Council of South Africa and the South African Institute of Electrical Engineers and Institute of Mechanical and Electrical Engineers Council of South Africa. He is currently serving as the chairman of the SAIEE Rotating Machines Section and a member of the Eskom Steering Committee of Rotating Machinery. So with no further ado, I introduce Jabu Bembe to you guys. Over to you, Jabu.
Thank you very much, Joanne. Well, welcome friends, colleagues, and those that are just visiting, and looking forward to a very eventful presentation from Nico, our own. We know we've got very fond memories with Nico. We've been with Nico for many years, but however, he's now over in New Zealand, and we're looking forward to him sharing us some of the things that he's doing up there and how we can benefit as well as South Africans. So thank you very much, Nico. Just to give you a brief in terms of what Nico has been up to. Nico is currently a University of Pretoria graduate. He worked as a generator engineer for Eskom until 2019, and now works at Mercury Energy in New Zealand as a generator engineer. Nico is an honorary member of SAIEE and the outgoing chairman of the SAIEE Steering Committee, A1, after fulfilling this role for the past 6 years. I think the one thing that Nico maybe forgot to put there is that he's also the member of the RMS section or the SAIEE. Nico, please put that. You also are a member. We haven't resigned. Thank you. But not wasting your time, Nico, can you go ahead with your presentation? Thank you.
Thank you very much, Jabu. Thank you for the introduction. Yes, so good morning, ladies and gentlemen. I've put together a few slides, and I'll share what I've learned in this past year in New Zealand. I'm still learning a lot, so this is by no means complete. There's still a lot to learn, and so I'm no expert of the power system here. I'm still learning. It's quite a different system, quite a different setup. Working for 20 years in Eskom as has molded you into a certain way of thinking. And then when you start working in a new company with new processes, new systems, you start missing how things were, because you are so used to how things were. But I think it's also a big eye opener to see how things have evolved this side. So hopefully some of these slides will give you some insight in what could be the future of the power system in South Africa. So yes, just a disclaimer, I am no expert of the system. I'm just sharing my opinions and views of information that is publicly available, and I hope you'll find it favorable and informative. And then please do ask questions. I've tried to cover what I think is interesting to me, what I've learned since I've started here. It's these new systems, new processes, new ways of generating power, which I've never been exposed to in South Africa. So that was quite interesting for me, but you might have other questions. So please make sure to post your questions in the question box, and then I can answer those questions during our Q&A session at the end. Maybe just as to start off this presentation from me, just in broad, the New Zealand electricity system was exactly the same as Eskom presently is. It started off exactly as a government run company, which was centrally run, and it provided generation, transmission, distribution, as well as retailing. And it fulfilled a role exactly as Eskom does presently until 1987. Government has initiated some reforms to start separating this monopoly and to open the power system for independent producers, retailers, and I think that's exactly the same route that government envisages for Eskom for the future. So this reform has led to the separation of the monopoly elements from the contestable elements to create competitive markets in energy retailing as well as generation. Regulation has also been imposed on the natural monopolies of transmission and distribution. I think our transmission system is massive in South Africa. It's quite a big system, and we probably need to retain a lot of that if we want to move into a more independent production system. And I think New Zealand has gone that way as part of their planning in the early days. The market consists of regulation, administration, generation. There's market clearing, transmission, distribution, metering, and retail. And there's a lot of different smaller businesses that has evolved out of this big monopoly, doing all of this, focusing on each sub system to make sure that whatever is generated is sold and gets to a customer. The owner of the national transmission grid presently is Transpower. It's a state-owned enterprise. Transpower is also the system operator responsible for ensuring real-time electricity supply security and quality, similar to what transmission is presently doing in South Africa. Transpower is the market scheduler, predicting demand to help generators make offers, as well as the dispatcher, and in charge of matching demand and supply in real time. And what I've realized here is Transpower is quite central to everything happening in a power system. You have, you'll see later through the slides, there's a few independent generating companies, and all of them are controlled and regulated and managed via Transpower. Transpower is directly involved with all the outage scheduling, all testing that happens during commissioning. Test plans has to be submitted well in advance. So the central point of communication for all power companies is Transpower. They play a key role in making the system work and keeping the system functional and reliable. Distribution of electricity from the grid exit points to the end customers, end consumers' premises is responsibility of about 30 distributors. They are also known as lines companies, and they have a monopoly control of line services on their networks. So it's smaller individual companies that would take power directly from Transpower's transmission network and deliver it to each home. But they are just a carrier between the retailer and the generator. So it's quite different to see all these private companies each taking part in this whole distribution of energy. Ownership of these distributors is through trust-owned companies such as Auckland Energy Consumer Trust, as well as various public companies. And this slide, for me, kind of gives a timeline of how things changed in the New Zealand energy market. And I think it's probably how it could evolve in future for Eskom as well, if Eskom is eventually following a similar route. And I think what's quite interesting is to see the duration of such a change. It's not going to happen overnight. It's going to take years for a system to evolve into something that's functional, independent, that can be profitable to various asset management or asset managers through this energy production, transmission, distribution, retailing system. And as I've read through some of the history as well, there was also a lot of union involvement. Whenever a decision was to be made, it used to be postponed because there was also issues around it, infighting, people not all agreeing to the correct way forward. So in between this, these blocks on the left-hand side, we don't see all the politics involved and all the fears, and because I can just imagine how much fear there was with between or among workers, among management. We're not so good in handling change always. We always think that we are quite ready for change, but we are not. And whenever there's changes facing us, we get we feel cold and we feel alone and we get scared. And I think that's the same thing from discussions with people who's been through this process through the maybe past 20 years. You get that feeling that they've been through the same issues, same problems, same worries. So I think where everything started was a decision by government in the 1980s, the New Zealand Electricity Department, which is exactly basically what Eskom is now. They were managing generation, transmission, distribution. It was a government department, controlled and operated almost all of New Zealand's electricity generation and operated the electricity transmission grid. And I think maybe in the case of New Zealand, it was even maybe a bit more government controlled than what Eskom is now. Eskom is a lot more independent, as it's used to be a public company, and now government is involved, but it's kind of still managed on its own, whereas the New Zealand Electricity Department was completely government managed. But the government of the day made a decision that it needs to change, and so I think the next step after they've decided that this monopoly in power generation and transmission and distribution and retailing has to change, they've created this Electricity Corporation of New Zealand Limited. It was also a New Zealand state-owned enterprise with heavy involvement from government. It's just the next step into transformation, but still same ownership. But this SOE, or state-owned enterprise, was formed on the 1st of April 1987, and this was kind of the first step into change, into getting a more open system. This was a transition entity in the process of deregulating the New Zealand electricity market. This step following this was to separate Transpower from this electricity corporation. And Transpower was then created as a separate state-owned enterprise. And their sole function and role was to own and operate the national grid. And I can just see how presently with this changes in Eskom having transmission, generation and distribution dissolving into 3 different entities, it's exactly what happened in New Zealand, having Transpower separated from the generating assets as well as the distribution assets, and give them full control over the complete national grid. The Electricity Corporation of New Zealand was then split into 2 separate state-owned enterprises. That happened then in 1996. So if one can look at just see what decision was made by government in 1987, with a first step of creating a state-owned enterprise. So from 1987, it's 11 years until 1996, where physical action was taken to change the generation aspect of the power system. 9 years is quite a long time, and we always expect things to happen quickly. It doesn't always happen so quickly. So this Electricity Corporation of New Zealand was split in these 2 SOEs. The one part of it was still called Electricity Corporation of New Zealand, and then a separate entity, Contact Energy, was created. Contact Energy would then be the first independent power producer, the way that the contacts that we use in South Africa, they would be the first independent generator as a test, and to see how the system can work and if it will be functional. After they've split it, Contact Energy with certain assets into Contact Energy, and proving to be a workable concept, in 1999, the rest of the generation assets were split up. So the remaining part of Electricity Corporation of New Zealand was then split into 3 separate SOEs with the names of Genesis Energy, Meridian Energy, and Mighty River Power. So eventually, all generating assets which belong to the government and to the state-owned enterprise was divided up among Contact Energy, Genesis Energy, Meridian Energy, and Mighty River Power. Mighty River Power derived its name, you'll see later, what the river does, but this Mighty River Power is the Waikato River, which most of the Mighty River power stations are situated in. Mighty River Power later changed their name then to Mercury Energy to be to be more reflective of what they do and their modern views of thinking and doing business. So the present electricity system, as it is today, have 5 major generators. We have Contact Energy, Genesis Energy, Mercury, which used to be Mighty River Power, Meridian Energy. So these 4 were the original state-owned enterprise assets, which were then divided between these 4 companies to manage all the generating assets. Trust Power is a 5th one, and you'll see also later Trust Power was mainly a municipal generator, distributor. I would think maybe very similar maybe to how Cape Town or Johannesburg or Tshwane is dealing with their generating assets as well as distributing their own generated power. So Trust Power was derived from a similar system like that. These 5 power producers presently produce about 95% of New Zealand's electricity. There is a whole lot of smaller generators, either producing to a specific business or also producing to be distributed into the grid. But mainly these 5, Contact, Genesis, Mercury, Meridian, and Trust Power, are the large power producers in this electricity market. Meridian Energy, Genesis Energy, Mercury Energy are all still majority owned by the New Zealand government. 49% is public and 51% still belongs to the government. But from what I've seen and realized is government they're not involved. You don't see them. I think they are a very silent partner, just maybe keeping an eye on their business, but I've never seen their direct involvement. Maybe I think they are more involved kind of driving policies, trying to get New Zealand into a greener atmosphere, a greener generation area, but not in day-to-day business at all. The COE and the board is directly responsible for the profitability of these companies, and they are in direct competition with each other in a day-to-day business sense. Contact and Trust Power are 100% publicly traded companies. There is no government involvement in them at all. An important feature of the New Zealand market is that all the major generators are also having their own retailing arms. So these companies would generate the electricity, but then also directly sell to customers. So they are physically involved at both ends of the energy spectrum. They'll generate their power, but they also have to then market, sell, and bill their power. It works quite well. I think it brings about a lot of competition between companies to be dynamic, modern, think of new ways of getting the energy to customers quicker, more reliable, without any hassles. If you change house, within one day your power system is switched over from your old house to the new house. You have a nice app to show you your hourly consumption. Everything is just done well to make it worthwhile for the customer to stay with that company. But there's many more retailers. Each generator has its own retailing company or retailing arm, but there's many other retailers in between which are purely trading energy, that would buy energy maybe from Mercury or whoever is cheaper for the day or who's ever cheaper for the hour, buy from them and then sell to their own customers. I think it brings about a lot of competition and making the system very transparent, and I can't really say it keeps their power cheaper, but at least there's competition, and it makes their service very reliable and easy to use. Retailers purchase electricity from the wholesale market and on-sell it to customers or consumers. Competition for retail customers vary across the country, but since 1999, when a full retail competition was introduced, customers have switched at a rate between 9 to 14% between different retailers. Government is operating a website where you can enter your postcode where you live in your town, and this website will compare prices between all the generators and all the retailers, and it will give you the cheapest electricity price, gas price, and many of these retailers also offer a bundle package where they will give you gas, electricity, and fiber broadband. And if you take all three from the same retailer, you get a discount from this package. It just opens up the business for good, maybe good deals. I see some of the generator retailers will give you a large big screen TV if you would take power from them, or internet from them combined with gas and electricity. So there's a whole lot of bundle deals that they play off against each other to get more customers. Gentailers are modern, they are dynamic, and my opinion is it's because of this direct involvement with the customer. If the generator was purely sitting as a generating asset feeding into the national grid, and retailers will then just be involved on the other end, I think it would still become a similar system to what we have now. We have generation completely divorced from transmission, completely divorced from distribution. But by having generators and retailers one company, you kind of make the whole system a lot more dynamic and modern. The whole image of the generator has to now sell its own product, and it works well in this system. Just a bit about the installed capacity in New Zealand. New Zealand population, I think, a few months ago reached 5 million. It's the total generation that's installed is 9.3 gigawatt. So it's just giving an idea of the size of the system. It's a different one can't compare the size to the system in South Africa. I think there we have, there's probably around 60 million people with a larger installed base. But just gives this at least gives a context to the size of the country versus the installed base. And there's a lot of margin or additional capacity available as surplus in a system. Wind installed base 659 megawatt, and this is quickly growing. Each of these generators, as well as some new generators that's getting into the market, are building wind farms all over the North and South Island. So this is probably the biggest growth area in generation that will probably happening going forward. Hydro is New Zealand's major source of generation. The North and South Island together has a capacity of 5.5 gigawatt. Geothermal, which is a very new concept to me, which is quite clean and very good system for a baseload generation. They have just above 1 gigawatt of generation. Coal is about 500 megawatt, gas about 1.1 gigawatt, diesel, oil about 155 megawatts, and then cogeneration about 277 megawatt. So they have a wide spread of different technologies with hydro as the main source. Of course, this is a bit of a risk. If you have a very dry season, your hydro is directly affected. And we had a bit of a dry season this past season. I think past 2 seasons was relatively drier than normal. I think we have El Nino taking place, and so rain is not coming as frequently as expected. For me, it's quite favorable weather. I'm not used to this constant rainy winter season, so we had quite a lot of sunny days, but it's not good for hydro generation. And then the government is aiming to be completely renewable by 2035. And there's also talks, the Labour government was just voted in again for another 3-year term, and they had a big majority vote. So there is a few policies that they might push through, and some of the speculation is that they would maybe bring renewable, try to get it 100% renewable by 2030, and that will directly impact some of the other generators who has coal in their fleet. We'll see later some of those generators. So yes, this is a spread, North Island and South Island. Wind on South Island is quite low, but there's a lot of hydro generation taking place in the South Island, which is also a problem presently, which I will discuss through my slides. Here you'll see the annual generation through different technologies. The top blue is hydro. As you've seen, that's the biggest installed base. What is interesting is to look at the portion of natural gas generation, which is relatively quite high, and international gas prices is hugely affecting the electricity market. But the last probably 6 years, natural gas have been used less and less, Geothermal has been brought online in a marginally larger rate. So geothermal is presently now the second largest producer of energy. And then all the others, there's a bit of waste heat, wood, there's some wind generation. You can see since 2004, wind has gradually been going up, been stagnant for a few years, and then lately, last few years also, new constructions as well as planned constructions to take place in future. And coal has always played a role in this mix. So if government is planning to go 100% renewable, coal will definitely have to go down to zero. And so there'll have to be plans how to balance that part of it. So renewable generation make up 83% of New Zealand's total power generation. So the remaining 17% will have to be quickly phased out and made up of other renewables if we want to reach a target of 100% by 2035. Hydro generation is the major contributor to renewable generation, but this is directly affected by our seasonal hydro conditions. Geothermal generation represents 17% of the total New Zealand power generation. For the year 2019, that was about 7,439 gigawatt hours. Wind generation presently is the major expansion area in the renewable energy sector. And then there's one major thermal power plant in New Zealand, which is Huntly Power Station. There is other smaller as well, but I think this will be a major impact to its owner when coal has to be phased out. Just an interesting slide to also show the impact of COVID. I think this happened to all countries all over the world. During our lockdown levels, we had basically 4 lockdown levels. Level 4 was our main, most strict lockdown that we experienced through this COVID crisis. And one can see how immediately power consumption reduced in a matter of days. Businesses closed, people had to work from home, same story all over the world. And then as we gradually moved out of the different lockdown phases, how the economy kind of got back up and electricity consumption normalized again. The light gray line at the back, that is the previous year's consumption, and the green line is this year. And then yes, once we've got out of level 2, it kind of normalized and was equivalent to what it used to be a year ago. So it's quite interesting. This is just an overview of Mercury. I work for Mercury, so I have maybe most information about Mercury. So I'll just share some interesting information on them. As you've seen in the beginning of this presentation, these companies were born from a reformed New Zealand electricity sector. Mercury was specifically born on the 1st of April 1999. It had the name of Mighty River Power, and the name came from where the assets were mainly located when this transition took place. Its brother or sister companies is Genesis Energy and Meridian Energy. At that point in time, I think they were maybe sister companies. Now They are huge competitors. I think they're more like brothers now, with a lot of probably stealing each other's employees and trying to get competitive edge above the other. So one thing that just surprised me is how easily people move between companies. I think this is also something that one should look forward to, is if you work in one company, you kind of stuck to that company. But here, having multiple companies in the generation sector, people have a lot more options. So it kind of makes the labor market a bit more liquid. So when this complete reform took place, Mighty River Power, which is now Mercury, took ownership of the 8 hydroelectric power stations that's in the Waikato River. In 2000, Mighty River Power purchased into its first geothermal power stations as joint ventures with local trusts. So the geothermal power stations were not part of this breakup deal. They came later as new investments, and most of these investments were done in collaboration with local trusts who owned a lot of land where geothermal resources are available. So the trust will then go into a joint cooperation or joint venture with energy producers to utilize this geothermal resource to then earn money for the trust. National government introduced a mixed ownership plan in 2011 to sell off 49% of its shareholding in generating assets to private investors. So up until 2011, government still kind of owned these assets fully. Only in 2011 the decision was made to sell off 49% to private investors, and this only took then effect in 2014. Mighty River Power changed its name to Mercury New Zealand Limited on 29 July 2016 after merging its retail and generation businesses. And it's before my time, so you can see how much energy Mercury put into marketing now of their new brand, of their new name, new symbol, and how they then went into a phase of creating a proud brand. And I can just imagine how much effort it took, how much dynamic thinking in that it had to take, how they had to modernize an old concept to just be wanted, to get customers to sell in, to buy into it. Mercury presently generates about 17% of New Zealand's energy, and mainly from hydro and geothermal generation. The company is 100% renewable. They do not have any coal-fired assets or gas-fired assets, purely hydro, geothermal, wind, and then solar. And then, as I've said before, it's one of the 5 generating companies servicing New Zealand, part of the Genesis Meridian Contact Energy Trust Power competitive group. Hydro is one of Mercury's main energy production technologies. So the Waikato River flows out of Lake Taupo. So Lake Taupo is quite an enormous lake. It's the largest lake in New Zealand. It's 46 kilometers long, 33 kilometers wide, 186 meters deep at its maximum point. It's a natural lake. The outflow of this lake is controlled by control gates. to regulate the flow of the water into the Waikato River. The lake size is the same as the land size of Singapore. And this lake formed from one of the largest volcanic eruptions to ever occur anywhere on Earth. There's some local tales where people said that the eruption of this volcanic of this volcano was even covering the skies of Europe. So yes, that's all folk tales, so you will never know if it's true. But in comparison with the biggest eruptions ever to happen on Earth, Lake Taupo is this one, and just the amount of material that were blown up into the sky was a lot. And for this lake to form, what happens is all this volcanic matter is blown up into the air, but as it's erupting, it empties everything underneath it. And as the earth hollow out from this volcanic matter, it at some point just implodes and then create this massive lake. And it's quite a beautiful scenery with some mountains full of snow at the back, Tangariru crossing, and it's really a beautiful lake to see. The level of this lake is only allowed to vary by 1.4 meters between maximum and minimum. So even though this lake has an enormous depth, it's not allowed to drop less than from its maximum point to drop less than 1.4 meters. So it's quite strictly controlled. It's a big environmental concern should the level drop too low. And New Zealand is very serious about the environment, so they take good control with massive penalties if this lake level would drop too low. And Mercury is completely responsible for the flow out of this lake through the power plants into the east coast. So yeah, Mercury has a big risk on them if they do not control this. Just see if this video can play. Hope I'm not messing up the presentation now. Let's just give it a minute. So this is the control gate where water from the lake is regulated into the Waikato River. Okay. So I'll get back to the slides. I understand there was no sound coming through. So yes, those were some of the power plants that's part of the Mercury asset structure that was given to them, or that was part of the deal that came from government at the point of the change in the electricity system. So all of the Mercury hydro generation assets is situated in the Waikato River. The Waikato River outflow is from Lake Taupo. In the beginning of the video, it showed Lake Taupo. This is the Huka Falls. This is directly after the control gates. So quite a beautiful blue, really a good color. It's really a beautiful waterfall with massive force. There are some of these large jet boats that would go full power against this flow, and it's no match. The boat, the river is just too powerful for whatever you put against it. So the river flows out into the Tasman Sea in the south coast near Auckland. River is 425 kilometers long. You can see there's Lake Taupo, and this river then stretches all the way north until it gets out into the Tasman Sea. All the assets are placed in this river, and as I've said before, Mercury control the flow, all the dams that's in this river, so that they can manage the flow through the turbines. There's 9 power plants. It's 8 power stations, but Maraetai, you'll see there's Maraetai 1 and Maraetai 2. They're feeding from the same dam, but it's quite an important asset during peak hours, where there's 5 units per station, so all 10 can produce all at once during peak hour. All of these situated in the Waikato River. So this was the original plants that were handed over to Mercury as part of the deal and part of the breakup. This is just beautiful scenery from the power plants. This is from Whakamaru Power Station. This is at the Maraetai power plant. So the beautiful vegetation, I think you saw on the video as well, it's always green. So some of the new assets that was then added by Mercury after this, after they semi-privatized, was to go into co-ownership with a trust in geothermal power plants. So steam wells are drilled. These wells are in excess of 3 kilometers deep. And it's also quite interesting to see how they have directional drilling, where they can actually control the tip of this drill to eventually go exactly where they want it to go. And as they drill, it gathers data of the formation, which get analyzed, and eventually they can redirect the tip to eventually reach the geothermal active areas. Steam temperatures can reach up to 375 degrees Celsius. The steam just constantly comes out, so all these power plants are baseload stations. If you want to control the steam, you'll just have to waste it. So it's all baseload. They try to keep these units full load 24/7, and they don't use them at all for any peak loading. The energy, the water then that's been through the turbines, then just get re-injected into Earth, into the geothermal space by injection wells, and that distributes back through the thermal, through the rock, heats up again, and it goes through the turbines. There's also two different technologies. Here you can see they pump steam directly through the turbine and back. The other system that they use, make use of pentane. Pentane has a very low flash point, so they would use the steam to heat up the pentane. Pentane is then used to drive turbines. And the benefit of pentane is it's clean. It doesn't contaminate or add any dirt to your turbine blades. It's quite a clean process. The largest geothermal plant presently in New Zealand is Naavapurua, or NAP. It's 135 megawatt steam turbine, and it's the largest single shaft turbine in the world. So in our minds, it feels small, but for this technology and being a single shaft turbine, it's quite a massive turbine. Geothermal generation, which Mercury either operate or own, is a Rotokava, which is a pentane plant, Ngatamariki, which is also pentane, Mokai, which is a combination of steam and pentane, where they have two large steam turbine generators, and then a whole lot of small Ormat energy converters using pentane. And then Kawarau, which is purely steam, and Naavapurua, which is also purely steam. Mercury presently produces 52.7% of New Zealand's geothermal generated electricity, which accounts of 385 megawatts. And then geothermal generation are all baseload stations on load at full load 24/7. And from a rotating machine point of view, I think that is what we like. We don't like these machines to go up and down all the time. So when we do a rotor inspection, everything just looks like new. There's no wear and tear to rotor insulation, or deformation of rotor coils, which is always really nice to see. But there's other issues. Nothing is always perfect. The generators that's used in these geothermal plants are all 11 kV machines, air-cooled generators. The generators connected to the steam turbines are 2-pole generators, but for the pentane OECs or Ormat energy converters, they use 4-pole generators. And the largest generator used presently is a 30 megawatt generator, driven by two 15 megawatt Ormat energy converters. So these turbines are installed on both ends of the generator, so both the exciter end, and here they call the other end the non-exciter end, which is I think better than turbine end, an opposite turbine end. Gives the exciter a bit of a nice flavor. But so the non-exciter end as well as the exciter end both have a turbine connected to the shaft ends. These generators operate in I think somebody's mic is on. There's some disturbance. Generators operate in a high humidity as well as H2S environment. It always rains in New Zealand, so the humidity is a natural part of that. But then in these geothermal sites, there's a lot of hydrogen sulfide. So this directly affects some components in the generators. On rotor coils, if your rotor coils are not silver plated or tinned or painted, you immediately see the corrosion on. See this. Where this noise are coming from. Anyway, so this H2S, and I think that's quite interesting for our rotating machine colleagues, it's directly affecting this outer corona protection. There you can see the stator core. There's the end of the core, your pistoids and your press fingers. And there's the start of your stress grading. And then between the core and stress grading, you have this bit of outer corona protection, and it just destroys it. This is a face connected bar, and there's the erosion just taking place. And this machine is 4 years old. This is not an old machine. This is a 4-year-old machine that that looks like this. So yes, this H2S environment is quite corrosive. And then the natural product of this high PD or high partial discharge is ozone. And ozone, again, is extremely corrosive. So anything inside this machine that's not protected by a corrosive resistant layer gets heavily corroded. All metal screws and copper cables and whatever it's metallic and exposed just corrodes away. So yes, unfortunately, there's always a negative to the positive. Wind generation. Mercury is presently building its first wind farm. It will be called Turitea Wind Farm, and it's presently in construction. It's near New Plymouth. On completion, it will be the largest wind farm in New Zealand with 60 wind turbines, each of 3.45 megawatt. They're using Vestas V112 WFET induction generator wind turbine gens. And the total capacity, installed capacity of this wind farm will be 222 megawatt with an estimated 840 gigawatt hour annual generation. This is just the foundation. This is basically what they are busy with now. All the blades, nacelles, everything is being transported or imported into the country and transported to the site or in storage locations. But for now, this is the civil construction phase. And I think this, we never see the actual foundation. It's always under earth. And I mean, compared to these humans busy up there, this is quite a massive, massive footprint for one wind turbine. So we just always see when the grass is grown and they call you for a problem, you never see what's happening under earth. Just a quick overview of Mercury's competitors. Genesis has a thermal generation component, which is Huntly Power Station. It's the largest thermal power plant in New Zealand. It has a 953 megawatt installed base, made of 2 modern gas-fired and 2 gas coal-fired generating units. They also have on the renewable side 3 hydro schemes: Tongariro, Waikaremoana, and Te Kapu. These schemes comprise of 8 power stations. 6 are located in the North Island and 2 in the South Island. Genesis also have a wind farm at Haunui in the North Island. This geographical spread of generation helps them to reduce the impact of localized dry periods. You always have to balance hydro with something else. Meridian, they have 202 wind turbines with an installed capacity of 417 megawatt. And then they have quite a large hydro generation. They own New Zealand's largest hydropower station, which is Manapuri, located in the South Island. The power station is 850 megawatts installed base. And they own 6 power stations in the Waitaki hydro scheme, situated in the North Island, with a combined installed base of 1,538 megawatts. And they also have a bit of solar. I think one thing that I've seen here, solar is not that big. I think there is a few local industries who has invested in solar to supply themselves, but and there is a bit of rooftop solar, but it doesn't seem to really have a huge it's not a big part of generation in New Zealand. Contact Energy, they have 2 power stations with a combined installed capacity of 784 megawatt. They have geothermal generation, 5 power stations with combined installed capacity of 468 megawatts. On the gas side, 2 stations with combined capacity of 629 megawatt, which is quite big. And then they have some open cycle diesel gens, 155 megawatts. And then Trust Power. Trust Power, mainly its background was as a municipal entity with some generation, transmission and distribution assets. Since the reform of the power sector, Trust Power added some generating assets to their portfolio, but I think mostly their aim is as a retailer. Presently, the hydro installed capacity is 431 megawatts from 28 power plants. They have a large range of small to medium power plants in New Zealand, and I think most of them are coming from their municipal generating history. I think why I'm showing these different parts of the business is just to see how they were split up. Each company got their bit of hydro or got their coal-fired combined with something else. But the idea eventually was to make each one of these businesses viable as an entity on its own, to make sure they are profitable and that they can operate independently from government or from any other support. And it's working well. I think in New Zealand, all these companies are profitable, they are dynamic, they push for more alternative energy resources. There was a lot of plans, there's still a lot of plans on the map for increased generating capacity, to build more geothermal plants, to increase the wind turbine footprint. There's also talks now to add some more seasonal pump storage on the South Island, just to help New Zealand through some of the climate issues that might become more prevalent in future with this climate change happening all over. So there's a lot of plans, but recently, just within this year, I think it was actually during lockdown or just after lockdown, Rio Tinto has a big aluminium smelter in the South Island called Tivai Point. Rio Tinto announced that they would close the smelter in the coming years. So that kind of brought quite a big shockwave through the electricity industry in New Zealand, as this aluminium smelter consumes quite a large portion of generated power. They consume 13% of the total national electricity. So it's quite a big chunk that will be missed if they would close. and it would also greatly affect Meridian, as they own this the hydro plant that's mainly feeding power to this aluminium smelter. TY Point is located in the most southern tip of the South Island, which is quite far away from the economic hub, which is Auckland, in the north of the North Island. So to get all the access electricity from the southern tip of the South Island to the North Island's northern tip, I think every network planner knows that complexity. And then between the South Island and the North Island, there's a big water mass where DC cables are the interconnecting point. And then the South Island is also extremely mountainous, so you can't just build a straight transmission line to take the power from the South Island to the North Island. There's a whole lot of things to get into place. So that's one place where I saw government now very actively getting involved in, and it's more to prolong the operating term of this TY Point smelter to make sure that they don't close immediately, to at least give Transpower some time to establish some links between the Manapuri generating assets and the North Island. But even bringing all that power to the North Island will still result in excess capacity. So this excess capacity has to be absorbed in future, and it just seems as if suddenly many of the generating companies who has planned more development in geothermal and wind generation sites to stop those projects until there's more clarity on the way forward for TY Point. So yes, a decision that's made suddenly, unexpectedly, can kind of change your energy landscape quite quickly. So yes, government is trying to smooth that out, but it still sends some shockwaves through, and people do not know what to expect in future. And I think one interesting thing, and I've seen some articles of this subject also in South Africa, that hydrogen generation could be quite big for South Africa, and the same with New Zealand. It's this whole concept of green hydrogen or clean hydrogen to power vehicles or to generate power with. It's possible to store it and quite effectively convert it back into electricity. So New Zealand is investing in some technologies for storage and generation, as well as usage of hydrogen gas. So there's various demonstration projects taking place all over the country. New Zealand has ordered its first hydrogen fuel cell bus, which have an estimated range of 500 kilometers on a single fill. A 1.5 megawatt hydrogen production plant is erected near the Mokai geothermal power plant. What's making New Zealand quite attractive for hydrogen generation is it will then be truly green, as they use geothermal or hydro generation to produce this gas. And I think there's some interest from neighboring countries to import hydrogen gas produced in New Zealand, because it would just make it possible for them to market it as purely green. So it is a bit of an advantage. And then the gas produced from these plants near geothermal power stations will then be used for domestic as well as the export market. So it's just something interesting, but I think it's taking off all over the world as there's new investments coming into clean hydrogen. So that's some overview of the system here. Just how I see the system, and I hope it will just inspire you also a bit to read up a bit more and just get a good feel for what the system in South Africa might look like in future. I think everybody was also scared here, and eventually it worked out well. People are happy, customers are happy because the power is reliable. Each entity is profitable on their own, which I think it's quite positive, and it kind of gives me a lot of hope for for what can come from Eskom in future. So if there's any questions, please, I will try to answer.
Thank you so much, Nico Smit, for your wonderful presentation. My first question is from Deepak Party. What is the percentage of renewable energy in New Zealand compared to non-renewable energy?
I think it's at this stage it's 87% renewable to 13% not renewable. So there's quite a big chunk to still change. I think what's important to note is that Huntly is Huntly Power Plant, which is the major thermal power plant in New Zealand, is also an aged plant. So there is a phasing out plan for this power plant. And I think if Huntly is phased out at some point, it's easier for them then to reach that target. But there's still a few years. 2035 gives them 15 years to get to 100%.
Thank you, Nico. There's another question from Dlamini. Hi, Nico. Is Elon Musk's giant battery contribution in preventing any power storage during the dry seasons where the hydro units are not performing effectively?
There is a few battery storage systems in place, but they are not enormous. They are not the mega or the giga sizes that Elon Musk tries to market. I see they're in a range of 1.5 megawatts. But I think for now, it might be something that they'll plan in future. Transpower was looking at upgrading some of the old assets, converting them into synchronous condensers. But at this stage, it's not economical yet. We have still a lot of baseload stations coming from geothermal, and then we still have all this water storage in Taupo as well as Manapuri that can cater for peak time. But I think for the future, definitely, they'll probably look at battery storage. At this stage, they are pushing for the seasonal pump storage in the South Island to build a big dam. There's a big thesis that was done about pump storage in the South Island. And it seems like the focus is now more driving towards pump storage. It just feels a bit cleaner than batteries. So I think that's what it will give government a nice image if they can talk about pump storage. But we'll see. Battery technology is really kicking off in Australia, so there it seems to be really helping their unstable grid. The grid in New Zealand is quite stable at this point in time, but adding a lot of wind can quickly change that. So it's something they'll have to focus for the future.
Thank you, Nico. I've got another question from Lorata. Hi, Nico. On your first slide, you mentioned the market clearing divisions. What would it function mainly be?
Oh, yeah, that's an aspect of the system that I don't know much about. So I don't think I'll be able to give you a clear answer on that. Sorry. All that I know is the bidding and trading system is working quite effectively. There's spot prices that everybody put a bid on, and all these retailers are quite active in this trading market, buying electricity cheap, and when it's low, and selling when it's high, and it's quite an active system. And I remember in Eskom we used to have a very active bidding and trading between the clusters, and here you can see it's really working well for this business. A lot of private retailers doing good business, but yes, I can't really give you a clear answer on market clearing. Sorry.
Thank you, Nico. Then I've got another question for Kupano. Does New Zealand experience load shedding like us?
No, I haven't had any load shedding anywhere. There's you sometimes read about an area where the power was off because somebody drove into a power line. That is headline news. But no load shedding. And I hopefully it won't come, but you never know. I mean, they rely heavily on the climatic conditions. So if there's drought, it might become a major problem in future. But at this point in time, they are quite still very fortunate with the lake levels and the rain we get to still manage the system well, very stable.
Thank you for that, Nico. And then our final question for today is from Nicholas Smith. What are the major differences in specs standards between RSA and New Zealand? Is it a difficult transition?
If you talk, the standards and specifications are very similar. There's everybody uses basically also international standards and specifications, so that's very similar. What I did notice here is they are willing to go the extra mile to ensure that quality is what they pay for. So they will sometimes you would think it's a bit too much, but then when you look at why they do it, there was learnings in the past, and I think we did the same in my past job, where you would try to take the learnings from a project and put that into your own specification to make sure that whatever you get from a supplier is better than what you had before. So here the generating companies are quite big on type testing, making sure that, especially on stator bars, and I think it's mainly because of this issue in a H2S environment, in a humid environment. They put a lot of focus in doing type testing on stator bars, pushing thermal cycling a bit further than what the standards would normally ask for. When you purchase a new rotor or a new stator, you'll also ask for some of the samples to be shipped before you would even accept the components to do your own analysis. So that they are on many aspects a bit more stringent than what international standards would be. So yes, it's a bit to learn as well, because if your previous experience was not to do so much additional type testing or factory acceptance testing, here every factory acceptance testing is witnessed. Nothing is accepted without a physical witness or factory acceptance testing. And during COVID, that kind of became a bit difficult because we were not allowed to travel. And then even your international contacts, third-party inspectors who could do it, were also not allowed to travel. So we had to do many of these factory acceptances via Skype or Zoom or one of these packages. And then the time difference is just difficult because they do the fat during daytime and we have to do the all nights. So there's a few things to get used to, and that's a little bit different and difficult, but yeah, we adapt easily. I hope that
Hi,
answers
Nico.
your question. Yes, Jabulani.
Sorry, Joanne. Just Nico, just to pop one question here from staff Bart at Matimba Power Station. He wants to know about your activities, your maintenance activities. Is it in-house or do you source people from outside? And also, just for me, from my side, there's one question: which OEMs have you got in New Zealand?
So maintenance activities on sites. On the hydro stations, many of the hydro stations are not manned. They run remote from central control, and they have a central maintenance team who will move between the sites. These maintenance staff is contracted, mechanical as well as electrical. If we need additional technical support, we would involve. We have ABB that's have good workshops in Hamilton that would have done many rewinds and refurbishments for all the power companies. They have good local resources. We have GE, especially on the hydro side. GE is quite strong with good equipment and skills and technologies. And then we have a big repair factory that the name of it is Milbank. They are also very good in doing rewinds and testing on site. So I think Milbank we would compare to what we have as Rotec. If we would need RSO testing or impedance measurements or a service or maintenance of a generator, we will involve Milbank. If we want to add, if we want to have involvement from OEMs, then we will mostly make use of ABB on the geothermal sites and GE maybe on the hydro sites. But we have a lot of good contacts with Fuji, with Voith, with Andritz, who has done refurbishments and upgrades in the past. And I think what's quite fortunate for me at this point in time, the hydro plants are quite old. Some of them have been in service since 1960s. So they have reached their near end of life. So within the next 10 years, there's quite a lot of refurbishments planned. And also when I started here this time last year, I was immediately into a refurbishment project. And they are just going to keep on coming, upgrading all these old hydro generators. So there's good support. But yes, all the day-to-day maintenance activities are contracted out. I just heard today that these contracts are about 3 years long, and then gets renegotiated. But there's a lot less rules around who you contract, so you kind of can push for technical quality a little bit more. But there's also a big focus on savings. Of course, it has to be a profitable company. You have to make sure that you do not overpay for the service. So I think that's the other aspect, is just to make sure you get value for money. I hope that answers the question.
Okay. Thanks a lot, Nico. Joanne, I think we've covered quite a lot, and I know our listeners and colleagues and attendees, they still want to ask more questions. However, we would try and address as many as we can. But what you can do, as Joanna said earlier, you can actually post your questions on the SAIEE website, and then we'll try and direct them to Nico, and then if possible, we'll come back to you as soon as possible. And also just to mention as well that we have a forum meeting following now at 1 o'clock, and we have a lot more for you in store in terms of the discussions similar to these ones, and then some of the presentations as well that are based on the on the plant work down where it's very difficult for these days to go to a plant, but we're looking forward to presentation that talk to a virtual plant work done. So join the webinar at 1 o'clock for the forum meeting, and we thank you very much. Thanks, Nick, for your presentation. I think it was spot on, and it just talks to our condition in South Africa. And we know that, from this we are strengthened that we're not the only country that is going through such situation in terms of power, but countries all over the world are going through, and they've made it. And we're also looking forward to South Africans as well working together and also breaking this barrier of electric issue, and that we compare to the worldwide as everybody else as well. So thank you very much. Thanks to our attendees as well and friends, and we're looking forward to seeing you at 1 o'clock.
Thank you. Thank you.
Joanne, you got anything that you need to add?
No, thank you all for the attendees that has attended this presentation. Like Jabu mentioned, the questions and answers will be uploaded on the SAIEE website together with the recording of this webinar and the presentation. Thank you so much, Nico Smit, for your time. We do really appreciate your time and for giving a great presentation. Thank you all and have a good day. Bye-bye.
Thank you.
Just just wait. So how are the attendees going to get the link to our forum? How are we going to send that through?
They can email me, Joanne at saiee.org.za, and then I will send them the link to our RMS general meeting if they would like to attend our general meeting at 1 o'clock. I'll just repeat my email address again, Joanne at saiee.org.za. Thank you so much.
Thank you. Okay, just the last point also, if you have anything that you think you can share with the forum or with the RMS section for SAIEE, you are more than welcome to send that to Joanne. And if you've got any presentation that you think it will be worthwhile to listen to, please send it to Joanne and we'll consider and come back to you in terms of time and when that can be done. Thank you very much.
Thank you, Nikki, for your presentation.
Oh, thank you for the opportunity. Have a good day.
Thank you.
Thank you.
Bye-bye.
Bye-bye.